Okay, welcome back to the third part of the data exploratory analysis (EDA). So we've seen the correlation, we've seen the skewness, kurtosis, and all of that, the scatter plot. Now we should check a different exploration, which is mutual information. Now the importance of mutual information is that when you check correlation, as I said earlier, correlation just gives you the linear relationship. It tells you that when something increases, the other one increases or decreases. It checks the linear relationship. But it doesn't check all of the possible relationships. Like the relationship might be non-linear. The relationship might be monotonic, it might be linear, it might be non-linear. It could be anything. So we need to check all possible forms of relationship. So, and that's what mutual information does. So it helps us to reduce the uncertainty in what we are trying to predict. So when you are looking for the mutual information between, let's say, the feature and the target. So what that is telling you is that if you know this particular feature, you will be able to reduce some certain level of uncertainty in our target. Okay, so that's what mutual information is. But then we will simply just import a library that will help us to do that. We would not write the code itself. So actually I've imported it here. You would see that I've imported from scikit-learn import mutual information. So obviously, if you don't remember how to type this, it's quite straightforward. You can just use Google. You can say import mutual information regression, something like that. And then if you click on this, you can simply scroll down. You see it's in here, sklearn.feature underscore selection dot mutual information. Okay, so that's quite easy, so you don't need to memorize that. So you can just say from this point import what we need. Okay, I will go down and run that. Okay, so in here I will say mutual, let me say mi scores mutual information equals to mutual info regression. And then what do I pass in there? It's a regression. You need to pass in your input and your output. In a simple term, you need to pass in your feature and your target, because what you are looking for is that you are trying to measure the mutual information between a particular feature against the target. Okay, so we will do for 1 1 1 1. So I'll pass in my feature, which is X, and then I'll pass in my target, which is Y. Then if I check my mi scores and I run this, you will see this kind of returns it in the form of array. So you can maybe send this to a list, or maybe you turn it into a series. Okay, so now I will convert that into a series. So I can just say mi equals to pd dot series, and then I will pass in this. So if you do Control Enter, it tells you the data. So I will say data equals to mi scores, and then I need an index. So I will say the index will simply be, I think, x, dot columns, because then I can run this. Okay, so cement. So now this tells me that, okay, now for cement, this is the mi score. For blast furnace, this is the mi score. Okay, so the higher the number, the better information you have. Okay, so this is telling me that you will see that this order is quite different from what we got from the from the correlation. According to correlation was checking the linear relationship, and then it ranks age before cement. Okay, it ranks age before cement. But then when we checked the mutual information actually ranks cement over age. So it's telling you here, what mutual information is telling you here is that knowing cement gives you more knowledge about predicting the strength. So cement plays more role than age. In fact, you will, oh, I'm so sorry, I need to sort this. Age is still higher. I'm so sorry, I have passed the comments, that is wrong. So I will just sort this again. I will say mi dot sort values, then ascending equals to false. Then I run this. Okay, so in each way, age still comes first. Okay, so sorry about that. So in the regression, in the correlation, age was the highest. So also in the mutual information, age was the highest. So this tells you that if you have more information about age, then you can easily predict that. So good. And then water comes second here actually, but water is somewhere, I think water was the water is also not so bad. It was just negative. Okay, yeah, it was just negative. So the next one is cement. Okay, so if you have the information about the age, you have information about the water, you have information about the cement superplasticizer, and in here, fine aggregate is the least is the one that gives us the least information about the target. Okay, so age carries the biggest information, in short. So we can visualize this in form of a bar chart. Okay, so I can simply just say mi dot plot. All right. Yeah, mi is the plot. Yeah, mi dot plot. Then I can say kind equals to bar, which is bar chart. Do I need to say plt dot show? Okay, regardless, it's going to show. In order to take away this, I can do this. So now you would see that, okay, let me call this mi equals to this so that it makes sense. Okay, now I run this again. Okay, because I prefer it to be sorted. Okay, now it is sorted. So you see age comes first, then water, then cement, then superplasticizer, then unfortunately fine aggregate is the last one. So more information about age, the better the predictability of the strength. So this we will go to the last point, which is the multicollinearity. In the next episode, we will see what multicollinearity is and how we can calculate it using the various inflation factor. So see you there.